Now presenting on the S4 sponsor stage is Indegy. Please welcome founder and CEO Barak Perelman to the S4 sponsor stage.
Thank you very much. Good morning, everyone. Thanks for attending, and welcome to the, I think, first sponsored presentation today. My name, Barak Perelman. I'm the CEO, one of the founders of Indegy, and a few words of background about myself and why you should listen. In the past 15 years or so, been dealing with both cybersecurity on one hand, industrial control systems on the other. Before Indegy in the IDF, the Israeli Defense Force Intelligence, about 10 years there, which is where I guess I was lucky enough to deal with this esoteric area of industrial control systems. And about 5 years ago, we founded Indegy to bring our experience and knowledge into a product, into a platform, which provides security for industrial control systems. I hope that with this, I'll not mention Indegy anymore during this session, and mainly try to make it interesting and educational. One of the main things that Dale always asks for these presentations is not to go ahead and make the 101 security for OT or for ICS environments. So I'll be assuming that everyone is familiar pretty much with what is out there, with the different technologies. And what I'll try to focus on today is the discussion around the type of technologies to implement in a network monitoring or asset inventory or product, security product within ICS environments. And specifically regarding the technologies, the entire discussion that has been going on in the last few years around active versus passive. What are the different considerations? Is there one option that is better than the other? And hopefully making it somewhat technical. I'll try not too deep technical discussion and arrive to conclusions from that based on the experience that we've had with implementations in the past 5 years since Indegy. Please feel more than free, even though we're limited on time. If there's any questions, feel free to interrupt me even during. The more interactive this will be, I think the better for everyone, and obviously over the next few days. So I want to start with a metaphor or analogy or a game of critical infrastructures. And I want you to do a thought exercise before we dive in. And in that game that you're playing, you are walking around in a crowded city. And your goal is to know and gather as much information and details about the people surrounding you. You want to know what they do for a living. You want to know where they live, where they grew up, what are their ambitions, habits, etc. You want to know as much details as possible about them. You have two options for players in this virtual game. The first player can walk around and listen to everything that is going around them. Essentially listen to conversations between the different people in that public park, for example. And in that conversation, essentially pick up on details. We all, I think we all agree, it's important to listen, to understand, and then you can pick up on people's names, probably, because people refer to each other by name. Maybe someone has a discussion about how was work in the past week, so you'll learn what they do for a living, and essentially you'll activate your own human intelligence in order to analyze and understand what is going around you. Player 2, on the other hand, has another capability, and a very interesting one. The player 2 has the ability to ask people questions and hear their answers. So if I wanted to know where someone lives, I could just walk up to them, ask them, where do you live? And get the answer. I can do that in English or German, French, and whatever is needed in order to do that. So player 1 has that passive capability, listening capability. Player 2 has both of these capabilities. He can listen to these conversations and based on them, ask follow-up questions. Now let's go back. Why are we even talking about such analogies and what are we here for? So eventually, net, if I look at our website together with all of our competitors' websites, there's a few things that stand up in the common denominator, which are 3 value propositions that we're all looking for to implement in our environments. Number 1 is asset inventory. We want to understand what we have in our environments, and when I say we want to understand, it's not just an Excel sheet with IP addresses and vendors, it's a much more detailed asset inventory. I want to know each of my PLC, DCS systems, RTUs, Windows machines, what versions they are, what hotfixes are installed on PCs. I want to know what's the firmware version and the open port on industrial controllers, etc., etc. I want basically any piece of detail that is in my network. I want to gather it in an asset inventory system. I want threat detection, obviously. This is a security conference. I want to be alerted as soon as possible in real time with mitigation suggestions to understand any possible malicious activity that is happening in my environment. And I want vulnerability management. I want some sort of risk scoring of my environment, some tool to tell me if you have the resources and you have some budget, where is the first place in your network that you should upgrade, that you should protect further? What are the most critical and vulnerable parts of my environments? If we'll have time, we'll talk about bonus for those who want to excel, which is minimizing cost and also simplifying the deployment. If we're looking, I'm sure all of you have many, many locations that they need to deploy or need to consider how to secure. Obviously, putting a large amount of appliances in each and every location can be cumbersome, and maybe we'll talk about that as well. So with those three value propositions, now we're going on our road to understand what can bring us all that information at the level that we expect, that we want it to be. And this is where the discussion of active versus or active and passive comes into play. And I want to start with a definition of active, because in each industry, active means a completely different thing. And I want to clarify that for the purposes of this discussion, for the purposes of pretty much everyone that says active in ICS or OT technologies, what isn't it? So active is not scanning the network. Active is not port scanning or port knocking. It's not sending TCP resets, which is blocking. So active is not blocking, it's not a firewall. Active is communicating with the other devices in the network, essentially querying, asking questions. It is never about changing configurations. So if you can think about backup system, it can restore, change configurations. Think about a firewall or the IPS, it can block communications. Think about Tenable or Qualys, a vulnerability scanner, it scans and tries to exploit devices in the environment. When we say active, we only mean querying. What type of querying? Because that deserves a slide of itself. Essentially, maybe the key component when we say active, or what we believe to be the most fitted and safe for these environments, is querying using the native language of the device you are communicating with. Which means that if I have a Siemens device in my environment and I want to ask that device those questions that I mentioned before, what's your name, where you grew up, and I will communicate with that device in the Siemens native proprietary communication protocols. If I have a Schneider Electric, a Honeywell, a Yokogawa, an ABB, communicating with each device in their native communication protocols. If I have Windows machines, then I have plenty of possibilities on how to communicate with that, mainly WMI, that's the main method for querying Windows machines. We have SNMP and other queries that we can communicate with network devices. I would say the Windows and the network devices pretty much a solved problem in the world that has been going on in the IT side for years. And in a way, it's also been going around for industrial control systems. We'll talk about at the tail end of the discussion about different objections and questions that come up on active technology and why we believe, or I believe, they're not really challenging or relevant. And to summarize, active means querying, never changing anything, and it means querying in that native communications protocol and not encumbering the network in any way. Let's go through a few use cases to explain why that active querying brings so much more information and really helps us solve the problems that we all agreed upon, or you all agreed upon in the RFPs that you're publishing, that these are the main challenges that you want to solve. And let's start with a quick example on asset inventory, and I'll tie that together with vulnerability management, just because we're short on time today. So what are the different steps as we go around and build our asset inventory for the network? So very quickly, I hate to read slides, but very quickly, we want to identify the active assets in the network, right? First of all, we want to listen and see what type of communications, what devices can we identify by listening to an environment. Secondly, we want to discover dormant devices. We all have that computer, PLC, that is connected to the network. We forgot it's connected, or someone left it behind connected, and it's not active and not communicating in the network, but we want to know about it. So that's the dormant devices. We want to positively classify devices. This is an important point that often gets overlooked. If I see communication in the network, and it's a pretty trivial method to identify the MAC address of a communication and attach it to a vendor. And that's how many asset management tools, that's how they show you. You have a Rockwell device. The problem is that Rockwell provides both PLCs and VFDs and switches. So just by listening to that communication or attaching a vendor, sometimes you don't really know what type of device it is, which is something that you definitely don't want to take gambles and don't want to make mistakes, switching between routers, switches, and PLCs. Then, once we identify our devices, we want to collect all the relevant information from them. We want to then start building the vulnerability aspect, which is compare that to known exploits, gather information about firmware versions, about open ports, about default passwords, etc. Give that, and eventually give that a risk rating in order to have the risk posture of our environment. What I want you to think about is, in all these 7 activities, what can you listen to the network? And again, passive monitoring, sniffing of network traffic, span port, mirror port. Which of these can you achieve by simply listening to the environment? And I think, and I hope I'm objective here, that essentially most of the most critical steps in this process simply cannot be achieved by strictly listening to the network environment. Because if you want to find dormant devices, if you're just listening and they're not talking, I think it's pretty trivial that you won't be able to see these devices. Configurations. When you say you want the firmware version of a PLC, or you want the hot fixes that are installed on a Windows machine in order to know and control your environment, why would you expect that information to go over the wire? Now, I'm not saying that it doesn't. A firmware version of an industrial controller can go over the wire once a week, once a month, depending on the engineering activities. Why would you want to be dependent on that? The list of users using a Windows machine and the hotfixes installed, I feel comfortable saying it never goes on the wire. There's no reason for these assets to transmit that information, definitely not in a way that mirror or span port can listen and analyze it. So again, not very objective, but objective because 5 years ago, these are the thoughts that we had, that it's simply impossible to gather all this information that we're very much looking to find. I can go on and on. The list of open ports on a device, again, something that I think by definition you want to know by listening to the network, because you have to interact with the device and simply ask it what its configuration. So in the asset inventory use case, and maybe similar to the analogy we talked about before, it's very important to be able to interact with the devices to gather information. If we're agreeing, I hope, on asset inventory topics, now you'll probably tell yourself, okay, that's great, but I'm really here for threat detection. This is a security conference, your security tool. The classic anomaly detection mechanisms and artificial learning are based on sniffing of network traffic. So what's that got to do with active passive? So I want to go over a use case for that malware in the network that, God forbid, is trying to shut down a DCS, a SCADA system, or just wreak havoc in the network in its entirety. Typically, the detection of malicious activity itself in the environment, 99.9% of the cases, is based on network traffic sniffing, monitoring, listening to the environment. Completely agree, no arguments there. This is why I will always claim that active and passive have to work together. But now think about what happens 1 second after your security team got the alert about a potentially malicious activity that happened between device A and towards device B. You got that alert, and presumably you got it from 5, 6, 10 different tools that you have, because you're now doing a bake-off and comparing everything, and you have 10 different tools. They all gave the same alert. A, maybe depending on how deep they know how to speak German or French, they can tell you that a PLC is being stopped, the ladder logic is being changed, recipes, maximum temperature, etc. Your security team in the security operations center or anyone else will ask themselves many follow-up questions that they want answers to. First and foremost, maybe, what is the implication? If an attempt was made to shut down a controller, I guess the first thing we ask ourselves in order to understand how urgent this alert is what happened to the controller? Is it now shut down, or did nothing change? If someone or something tried to change the recipe on how to manufacture a drug, what was the impact? Was it changed, or what it's not, or wasn't it? Once I have that information, that context on the device that was targeted, the follow-up questions for the mitigation process and for the response process will pile up, because I want to know who's the user currently logged in to the originating device. Maybe I'm at a later stage of the investigation. I want to know what is the last piece of software that was installed on that Windows machine. Maybe that will help me understand how the malware got there. And I didn't even read the slide. Maybe there's a few more examples here. Key state, perfect example. We have PLCs, industrial controllers. They are simply on read-only mode and cannot be changed from the network. You want to know if that's the case or not? Again, goes to the urgency of the alert. My point being is that we're not reinventing the wheel by using active. I'm not saying anything here that wasn't heard by the IT security community before. If you think about IT security tools, try to think about the last pure 100% passive security tool that you saw in IT networks. I think you won't be able to think about one, because even the IDS, the intrusion detection systems that we have in IT environments, they understood a few years back that once you see something suspicious, once you identify something suspicious, want to raise an alert, what you want is provide more context. We all have plenty and enough of alerts as is. We want more context to be able to analyze, to be able to react quickly and react more intelligently. Which is why also for the threat detection case, being active to gather more information that doesn't go through the network is so important, so critical. One more bonus use case, which is actually one of my favorites, because it's always surprising to our end users, is that engineers walk around the facility, they walk around with their laptops, and they like it a lot to connect directly to industrial controllers, obviously sit down on a Windows machine, and make configuration changes. Now, think about it. How will you ever know about a change if it was done locally on the device by a USB thumb drive, by a serial port, Ethernet port? How will you ever know about it? It's essentially a person walking behind the firewall, plugging in and making changes on the fly that has no indication over the network, and you will simply never know about that configuration change unless you're able to ask the devices nicely, what are your latest changes, what is your current configuration. So that is another example on why threat detection benefits from that active component as well. I said I'll mention a few bonus items, so I'll go quickly through those. How many of you in your infrastructure simply have the problem of unmanaged switches in your lower end of the network? So even if you really wanted to do passive monitoring of each segment, you cannot unless you want to start buying tap devices or upgrading your switch system, something nobody likes to do. So if you don't have any managed switches, then suddenly active becomes pretty much your only option, or the only way to be flexible. Same case, even if it is managed switches, but you have a very large environment, you have many, many locations. You don't want to buy a monitoring device for each segment of your network, for each switch. But if you have that one device in the network that can essentially reach out and ask devices, then you don't need one in every appliance. Let's think about this event. I want to talk to people in the upcoming few days. Luckily, I'm here now, and I can walk to the other room and ask people questions in that room. And that is the parallel of active, the ability to reach out, to move around, and not just sit in this room and listen to conversations for the next few days. So again, benefits both on the flexibility and feasibility of deployment, also simply on the cost, because less hardware, and honestly, less hardware means mainly less maintenance for you. It's not about even the cost of the product, it's about the fact that we don't want to plug in more and more hardware if we even have room for it. Why am I claiming, I think a few times already, that active is so safe? And maybe that is the main objection that we tend to hear, and this is the main issue to discuss perhaps, on if we all agree that the value is there. Well, actually I think that the next slide is more interesting to that. I'll just go over the headlines here. Negligible network traffic, querying an industrial controller, gathering its entire configuration is a few hundred kilobytes. It's negligible, you don't need to do it every second. You won't even notice it in the network. Impact on controller performance, this is super important. The typical industrial controller has two processors, one to process whatever is coming from the network, another one to handle all the IOs and the devices. Network overload will not cause, even network overload won't cause failure with the IO devices. This isn't because Indegy is speaking with Siemens, Schneider, and Honeywell in order to change the configurations. This is because the engineers have engineering stations that create network traffic, and we don't want an engineer making a mistake connecting to a device, downloading its configuration, suddenly the plan fails. It's simply not a possibility, not an operational possibility, which is why it's not the case, and it was designed not to suffer from extensive network traffic if there was one to be. And eventually, by giving the user the mechanism to control the querying, you want it every 12 hours, you want it every 24 hours, you want it manual only, you want it only on the weekends. Extensive query configuration can also help you a lot with that. Even further, I want to say it here, even further, what we keep hearing? One, the ICS vendors themselves don't like it, we will void our warranty or something like that. I would simply define that as a myth. I've been searching for 5 years, I never saw that warranty document. It simply doesn't exist. One of the reasons is that ask your engineers, or if you are engineers, tell your IT colleagues that you have plenty of tools in the OT environment that are active by nature. Or I'll even say, you don't have any passive tools in OT environments. You have historians and HMIs and engineering workstations. All of those communicate actively with the industrial devices in order to gather information. And somehow there's no certifications, and there's no objections, there's no warranty issues. Nobody cares because it's okay. It's even healthy to gather information. If you think about if you have MDT autosave or if you have version dog for backup, that's exactly what these tools are doing. They're reaching out to the devices, querying their entire configuration. You never gave it a second thought if this is risky or not. Great. So the main point I'll say on this, if you're on the IT side, speak with your engineers and understand that it's the same that they're doing today. If you're on the OT side, question the IT, what do they plan to do with that active tool? Because I know the number one story we hear is that vulnerability scanner that was installed a few years back knocked down the facility, and that's why nobody is willing to listen to the word active anymore. We understand it completely. This is not the case. We defined active before. Querying, not exploiting, etc. I do want to show a 2-minute video as well, so I skipped a couple of slides. And so I'll start wrapping up. I focused on active because I think that's the interesting topic, that's the innovative topic, and that's what brings all the information. I want to make it perfectly clear. I'm in no way supporting an active only. I don't think that's all that valuable. I don't think it provides a solution. The solution is a hybrid methodology. In, again, my not very objective opinion, the solution is a hybrid model, passive and active. Listen to the people around you and ask them questions. There's a lot you can gather from monitoring the network traffic. I think it's all said and done. Just add another layer of the active querying component. Just before I finish, I want to you to hear it not only from me. City of Raleigh, Raleigh, my accent never gets it right. He will say it. They just won an award together with Accenture, IBM, Honeywell, some very large companies for their security plan, which we were lucky to be a part of, and I'll be happy.
The City of Raleigh is the capital of North Carolina. The public utilities has about 200,000 accounts and serves 500,000 customers. The utility has a technical applications group, which I'm a part of. That group is responsible for the SCADA network and security for that network, which is an important aspect of our public safety. So there were a few things that kept us up at night that the Indegy product provided, and what we were looking for was the active component. One thing that seemed like it was a real plus was the ability to actually query PLCs and then get back information on what programming changes had been made to the PLCs. Versioning information, we didn't really have in the past a way to get that version information as changes were made. Now we have a timestamp on when the changes are made, and we can determine who made those changes. The other vendors had a more passive monitoring solution. Indegy does both the passive and active component. It was a real value to us. We wanted to be able to provide some sort of accountability to our systems integrator who was making changes on a regular basis. And we just needed to be able to do some automated asset discovery. It's a huge job to keep track of various assets, and rather than spending inordinate amount of time trying to track those assets, the automation is a key. Within a matter of minutes of the time we had the Indegy device engaged, we were able to provide a huge amount of data on our network that would have taken weeks to gather manually. So the automation provided asset names and IP addresses, MAC addresses, and things like that were useful to us from a network management standpoint. That information didn't have to be gathered manually. We all had it on a single pane of glass on the Indegy console. Because some of the asset management is automated, I can spend less time on that and more time on looking at actual threats and vulnerabilities and then remediating those. Deployment went very smoothly. The RFP process took a lot longer than the actual deployment. The deployment was just in a matter of days. I was very impressed with the engineering staff at Indegy. They were very helpful, helped us work through any issues, and we were up and running. Basically, the first day, and then added some additional features as we moved along. I've been very pleased with the Indegy support and service. Whenever I have issues, the staff is very responsive. They're very knowledgeable, not only in their tool, but in other products and across the industry.
Is one approach better than the other? No. We're definitely not saying passive isn't good or something like that. We do it. We do the hybrid approach. We believe that's the right way to go. Are controllers that delicate? I have a minute, I have 30 seconds, nothing, 28 minutes. I'll leave it as a thought exercise. Controllers are like diamonds, right? Drop a diamond, it will break eventually, but if you use it like it was intended in a ring, scratch it all day long, nothing will happen. Same with controllers. Come with a hammer, it will break. But otherwise, it's the most resilient device you have in your environment. It's there 20 years, 24/7. That's its role, so don't be that afraid. Don't ask why should I deploy active? Try to explain yourself why not. Eventually, you might decide against it. Great, take it, put passive only mode. We'll meet again in 2 years and you'll activate the active mode as well. That's what we've seen around. I hope it was interesting. Thank you very much for attending.